Scratch is the perfect way to start learning game development. A simple jigsaw-like design that limits you to the absolute basics, but offers a lot more than you might expect. But what actually is Scratch? If you have no idea what Scratch is, it's a visual programming language developed by MIT and is used as an educational tool to teach beginners all about the inner workings of games and how they may be structured. This is all achieved by combining code blocks, costumes, and sounds to create a simple, fun learning environment to understand what makes games tick. But how does it achieve this? Well, game development is really complex. There are a lot of moving parts to games, and most of these are things that players don't even consider. From map generation to player controls to saving and loading data, things can get really overwhelming for first-time developers. And when you add the programming language with its own syntax on top of that, you might as well be looking at alien technology. When I first started learning programming and game development, I had no idea what a function actually was, or how multiple classes work together. So making a game was basically impossible the first time around. But as you start to understand each layer individually, it becomes easier to put it all together. And that is where Scratch excels. Scratch breaks down everything into manageable chunks of code and allows you to easily click them together to see what happens in real time. Starting with the very basics of movement and character control without needing to know what is happening behind the scenes in the code allows beginners to learn the concepts of development without also being weighed down by the technical side. So I've covered what Scratch is, why don't we talk about what Scratch isn't? Scratch is not a game engine in the traditional sense. It is not made to develop commercial products, and the games made with Scratch aren't meant to be exported and published. However, this is technically possible with a few wrappers such as Turbo Warp, and while researching for this video, I saw quite a few YouTube videos discussing the identity of Scratch, almost wanting it to be something it isn't. Scratch is very basic, and the code blocks it offers are rather limiting, and while I can see some features that would be nice to improve upon, a lot of the YouTube Scratch community isn't necessarily the target audience, as those looking to push Scratch to the extreme as a form of challenge would be encouraged to instead move on to more appropriate game engines. So we know what Scratch is, let's check out some of the games on the front page to see what people are making. The links to all of these games will be in the description if you want to try them for yourself, but let's get straight into the gameplay. The first one is a remake of the game Geometry Dash by Griffpatch. This thing is so well made and plays exactly how Geometry Dash plays. You jump rhythmically to a song, avoiding the spikes and drops. Obviously this is already an existing game, but it's really impressive how the dev has managed to create these scenes flawlessly. And the next game is also by Griffpatch, called Apple. It was a pure coincidence I clicked another of his games, but there's a reason he has multiple featured here. This one is a more typical platformer where you play as this square guy with a green plunger for a head and navigate your way through collecting apples. Again, it's very basic gameplay, but the level of detail and polish that's gone into it is seriously impressive. If, like me, you hadn't heard of Griffpatch before, he's a rather big Scratch-focused YouTuber that creates tutorials, devlogs, and hosts game jams for the community. If you're interested in learning more about Scratch, I would recommend checking out some of his content. The third game I played is a Pokemon-themed clicker game, one of the most iconic, simple genres for smaller scale games. In this one, you simply have to click the Pokeball to gain golden nuggets, which can be used to upgrade your ball, which in turn increases your nuggets per click. You also gain a Pokemon egg every 100 clicks, which can hatch into various Pokemon, which grant bonuses such as gaining nuggets every second. The game also has a prestige mode once you collect all of the Pokemon and balls to start again with new bonuses. These features are in basically every idle game like this, so the design is nothing new, but it's rather well put together and is quite fleshed out. I think if the Pokemon company actually made something like this themselves, it would be a massive hit, but at least we've got these fan-made games to enjoy. This is Ball Blast, another simple number-style progression game, with the sole focus being to pop the oncoming balls to improve your damage to then pop more balls. You play as this little cannon and fire at the bouncing balls, dodging them with left and right. The targets drop coins, which you can spend on upgrading the rate of fire, damage, and coin multiplier of your cannon. Again, you can see the style of game that Scratch is most used for, almost a successor to the old school Flash games, like the ones I covered in this video, and are more like simple one-shot experiences rather than a full game. The art and design in this game are really nice. Scratch works with vector art, so everything looks crisp, and overall is a pretty solid game to play. With these last two projects, I wanted to highlight some of the more advanced game designs, with the first being 3D Ball. This game is a 3D-ish platformer similar to the classic game Run, where you move a ball left and right to try to navigate the platforms. Like I said, it's 3D-ish. The game creates a 3D effect while still being a completely 2D game, and this effect is achieved with some basic shapes and perspective. As the platforms move closer to the bottom of the screen, they get taller, making it look like they are moving towards the camera. It's a simple trick that many games, especially older ones, have used, but it's rather impressive here being implemented in Scratch. And this final one is just crazy. This is Minecraft 3D, a fully three-dimensional game made in Scratch. And this is highly reminiscent of the classic 3D games such as Doom or Quake, with how it handles and renders the viewport. I can't even begin to explain how this works, but with Scratch's nice feature that allows you to see inside the project, you can see just how much goes into making this little demo work. The gameplay is, well, basically unplayable. Scratch doesn't support mouse movements, so the camera is controlled by the arrow keys, and for some reason the mining and placing blocks is bound to M, which is just about as far away as it can get for either hand. But the fact that people managed to get a 3D engine working inside of Scratch is simply impressive. So you've seen what Scratch is capable of. Now it's my turn to make something amazing. And as I'm currently making my game Zedcab, an arcade driving game in Unity, I thought I would make a very simple demake of that game here in Scratch. So here we are in a blank Scratch project, and this is what is provided right at the beginning. We've got the classic Scratch cat standing there, and if you start the game, it meows. Riveting stuff. But let's start getting our game together, and for that, I need some sprites. Now, I could just chuck in the pixel art sprites I already have, but Scratch actually supports vector art, so I thought I'd make everything look rounded and more cartoony. So basically, all I did was trace over the car with a thick brush, and it was done. Inside of Scratch, there's also a drawing tool to create your sprites, which I probably should have used from the beginning, because when importing bitmaps into Scratch and turning it into a vector, it doesn't have the same quality. So I ended up smoothing out the edges with this anyway, but here is a lovely car in Scratch. I also drew this amazing looking background with a single road that doesn't go anywhere, some houses around the edge, and a one-hole golf course in the middle. Whoever chose to live in this town has questionable taste. Around this time, I ran into a pretty big problem, and added quite a bit of time to this short project. But it wasn't actually anything to do with the project itself, more the PC that I was making it on. I was sitting down working away at the game, and suddenly my PC would just shut off. No notice, no heads up, nothing. Just silence. And that's pretty weird, so I tried to boot it up again, and it would go off. It was only after letting it sit for a while that turning it on again actually worked, which instantly told me that it was a thermal issue. To give you a little lesson in how PCs function, the CPU works its little magic and produces heat, and the CPU cooler and fan are supposed to deal with that heat, except the fan died. And it's not the first time this has happened. Since 2021, I have had 3 Noctua fans die on me, when everyone else online says that their stuff has lasted for a decade with no issue. I don't know if I'm cursed or the Austrians just don't like me, but this meant my PC was a very expensive paperweight until the Amazon delivery guy dropped off my replacement. I then had to drill through part of the fan casing to fit screws in because I didn't have the right length. It's not exactly the most elegant solution, but its idle temperature went from 100 degrees to 50, so it's safe to say that it worked. Now I can get back to making my silly little game. Right, so I've got the car, but how do objects in Scratch actually work? Well, down here, you can see the panel for all of your objects, and each object has a tab for their individual code, costumes or sprites, and sounds. The stage that you're on also has these properties, and could be seen as your game manager, where the overall logic is held, similar to how Unreal Engine has level blueprints. Coding in Scratch is very simple, and works by taking blocks from the library on the left and clicking them together. There's blocks for motion, looks, sound, events, control, sensing, operators, variables, and my blocks, which is where you can define your own functions and wrap them all into a single neat block. So the first thing the car needs is to detect input from the player and move accordingly. This one part took me longer to make than the rest of the game combined. I just could not get it the way I wanted. The first event block, which is similar to the start function in Unity, is called when the green flag is pressed, and connected to this event I had a forever loop to store all of the logic. I created a new block called WASD movement and began working away at getting this right. I started with 4 if statements to say if a key is pressed, then face in that direction. I assigned WASD to the 4 vents and it technically works. At the end of the code I added a move steps block just to always move forward in the scene. This input means that it would sharply rotate to that angle, and for some reason it was only working going left and right, but it turned out that in the object settings you can change the rotation mode to be free rotate, left right, or fixed. With that set correctly, the car can drive around, but it looks pretty awful, and obviously not how a car works in real life. So I then spent the next few hours fighting with rotational maths with a very limited toolset. So what I did was set up an X and Y variable for the movement. Scratch doesn't support vectors, only numbers or lists, which I technically could have used, but that's way worse than just using 2 variables. The idea was I could take these 2 values and calculate the angle of rotation based on them. At first, I set the values to the angle I wanted. For example, if you press W, you want to go up, and that angle is 0 inside Scratch. If you want to go right, you press D, and it sets the X direction to 90. If both are held, then you want to go diagonally up and right. This would add them together, divide by 2, and give you the target angle of 45. This seems like it's correct, except there is a massive issue that took me a while to get around. Angles in Scratch go from negative 180 to 180. Anything pointing to the left is a negative value, anything pointing to the right is a positive value. So if the X direction is set to negative 90, and the Y direction is set to 180, that comes out at 45 with this equation, which isn't right. And I basically spent a whole lot of time changing the numbers around, trying to get the absolute values, getting the mod value of the angle, so on and so forth, but I never actually got the issue fixed. Because when I would get something down that works in the problem direction, then another direction would just break. There's a whole lot of this going on, where the car just can't turn left.
I'm not an ambi-turner.
And how I figured it out eventually was just by mashing blocks together until they fit. And that is one of the nicest parts about Scratch. There's no compile time or anything, you can test code as you're building it, so if something doesn't work, you can keep snapping blocks together until it does. And finally, after hours of clicking number blocks together, I cracked it. The first step was simplifying the code for getting the X and Y directions. I found out in Scratch you can minus inputs to get the combined direction. So the Y direction is W pressed minus S pressed. If it's only W, then it equals 1. If it's both, it equals 0. And if it's S, it equals minus 1. And then the same applies for the X direction. I then added a check to see if both inputs are pressed, because this changes the calculations if they are. And then comes the angle maths. Brace yourself, this gets messy. So if the absolute value of 90 minus y dir times 90 minus x dir times 90 is less than 100, then the two are added together and divided by 2 to get the midpoint. If it's greater than 100, it means the angles are at that wonky point, and so it's then the x dir total minus the y dir total divided by 2 to get the target angle. If only one of the inputs is pressed, then it sets the appropriate target directly. And then I have the target angle, I have the direction. All that's left is to see if the car should turn left to get to this point or right. First, I added a check to see if the angle is within 15 degrees of the target, because then I just set it directly. If it's not, it's time for more maths. I check whether the absolute value of the angle minus direction is greater than 180 degrees. If it is, then that means that it is crossing the angle limit, so it needs extra attention. If angle mod 360 minus direction mod 360 is greater than 0, this means that it needs to turn right, and if not, it needs to turn left. Similarly, if it doesn't cross the angle limit, it just checks to see if the angle is greater than the direction, because again, if so, it turns right, if not, it turns left, and finally, the car rotates towards the target angle. And at the end, I added the little block to check if any input is detected, and if so, to move the car. I have done it. I have successfully added a somewhat smooth movement controller for a car in Scratch. Now it's time for the zombies, and luckily for me, this was a whole lot easier. Scratch has a block to rotate to face an object, so all the zombies do every tick is to rotate towards the car and take a step forward. But I can't just place the zombies in the game, I need them to spawn in. And that is where Scratch's clones come in. A clone is exactly what it sounds like. The game creates a copy of that object and comes with its own event that is triggered when they start as a clone, which is where all the zombie logic goes. So first, the zombie is enabled with the show block, as they are hidden by default, and is placed in a random position. And then a forever loop kicks in, which points towards the car and takes a step. In here is where the zombie also has the collision code. So by using the touching sensor, if the zombie touches the car, it dies and adds 1 to the kill count. Very simple stuff. But how do I actually spawn a clone? Well, that all takes place inside the stage code. In here, I need a timer that periodically creates zombie clones for the player to attack. So how I got this working is inside a forever loop, I spawn the zombie and then wait 0.5 seconds. There's also a limit to how many zombies can be on screen at once to stop it getting a bit silly, but that's literally it for the zombies. They spawn in and I can now run them down with the car. So the game needs something other than zombies to aim for, and as the last Zedcab devlog had Zuzu the duck appearing for the first time, I thought it was fitting to add her to the game here too. I drew up this beautiful looking sprite in Scratch, and there she is. Instead of building out a whole quest system in Scratch, because I do not have time for that, instead I'm going to spawn in an explosion when the duck is collected. So in the stage code, it has a 10-second timer that counts down only when there isn't a duck currently in the scene, and then when it hits 0, creates a clone of the duck. The duck, like the zombie, starts in a random position. I also need the explosion object for this, so I just grabbed the sprite sheet for the Ancient Tomes attack, cut out a few of the frames, and added them all as costumes to an explosion object. Within the explosion, on spawn, it loops through the costumes to give the frame-by-frame effect. And here is where I use the message system for the first time. A message is a very simple way to call scripts in other objects, and in Scratch, you don't have to worry about setting up listeners or anything like that. It just works. So I made a new message called Kill All that, well, kills all of the zombies on screen. So about halfway through the explosion, calls this message that all of the zombies receive, and in the zombie code, that message simply calls each zombie's kill function. And with the explosion spawning on collision with the duck, almost everything is now in place in the game. When the zombies die, they just disappear, which looks pretty bad. So I want to add an effect similar to that in Zedcab, where it leaves behind a pool of blood. Originally, I looked into spawning a new object at the zombie's location on death, but then came up with a really great idea. I just simply change the zombie sprite to the puddle of blood and deactivate all of its code. Then, after a few seconds, the object is destroyed. And that looks like this in the game. Very simple, but effective. The final thing to take care of is the audio in the game. And again, to do this in Scratch is very simple. By using the audio blocks, I can just play a sound when something happens. So in the zombie's kill function, it plays a grunting noise when it's called. And randomly, when zombies spawn, there's a chance to play an initial sound. To make it obvious the duck spawned, I wanted to add a sound effect to it. So I had a look at the sounds in Scratch's own library, and instead of going for something boring like a quack, I went for this great sound effect. And finally, the bomb. I wanted something with bass and power to emphasize the devastation, and I think I pulled that off. Bang. And that is my solid attempt at creating a Zedcab demake in Scratch. Overall, this project took me a few hours, and most of that was spent on a single maths problem, so you can see just how easy it is to get started with your game development journey. Scratch is an amazing tool to learn games, and I'm so glad that something like this exists, because it offers people a way into development with a straightforward path. And by holding back all of the technical side, it allows creativity to shine, so that people can feel comfortable making little games they like before graduating to the big, scary game engines like Unreal or Godot. And that's it for me. I hope you enjoyed this video. I had a really good time playing around with Scratch, and hey, maybe this isn't the last time I make something like this. So if you enjoyed this video, leave a like down below. Don't forget to subscribe, leave a comment, let me know about your favorite Scratch games, and I'll see you in the next one. Cheers.